There is an oil that costs $2 at any pharmacy or grocery store in America, lubricates metal under extreme heat and pressure better than standard petroleum products, and was the official engine lubricant of every Sopwith Camel, Spad, Theed, and It.The fighter aircraft that flew in the skies over the Western Front during World War I. Not an experimental alternative that engineers tested and discarded. The standard issue lubricant that every military aviation mechanic on both sides of that conflict used on every rotary engine that kept pilots alive in combat conditions no ground-based machine had ever experienced before. Temperatures exceeding 300 degrees. Rotational forces that destroyed conventional petroleum lubricants within minutes of operation. Pressures that squeezed conventional oil out of bearing surfaces and left metal grinding on metal at 800 revolutions per minute. Castor oil did not fail under those conditions. Every other lubricant available in 1917 did. That single fact determined which aircraft stayed in the air and which ones fell out of it, and the military engineers and aviation mechanics who discovered it did not stumble onto it by accident. They tested every available option under combat conditions and documented the results with the precision that keeping pilots alive demanded. The global petroleum lubricants market generates over $60 billion in annual revenue. Synthetic motor oils, industrial lubricants, and specialty mechanical compounds represent a carefully constructed dependency that has been engineered into every piece of mechanical equipment sold in the last 70 years. A $2 bottle of castor oil from the pharmacy shelf does not belong in that system. It never did, and that is exactly why no automotive parts store has ever put it in the lubricants aisle. This is the story of castor oil as a mechanical lubricant, the forgotten engineering solution that flew 2 world wars, that the petroleum industry quietly retired, and that any man with a machine and $2 can put back to work today. Welcome to Forbidden Camping. Subscribe and hit the bell. This is where we open the vaults the industry paid to seal forever.
Let me take you back to where this all begins. The year is 1915. On a British Royal Flying Corps airfield in northern France. A mechanical officer is standing in front of a Lorraine 9J rotary engine, the power plant of the Nieuport 11 Scout aircraft, with a serious problem and very little time to solve it. Conventional petroleum-based lubricants are failing under the operating conditions of the rotary engine design, where the entire engine block spins around a fixed crankshaft at speeds that generate heat and centrifugal forces far beyond what ground-based engines of the period produced. The petroleum oil is thinning under heat and being flung out of bearing surfaces by centrifugal force before it can provide meaningful lubrication. Engines are seizing, pilots are dying, and the mechanical officer has a crate of castor oil that arrived in the supply shipment because it was the only lubricant the procurement office could source in the required quantity on short notice. What he discovers over the next operational period changes military aviation. Castor oil does not thin under heat the way petroleum oil does. Its viscosity profile under temperature increase follows a dramatically different curve. It maintains usable lubricating film thickness at temperatures that reduce petroleum oil to a liquid too thin to stay between metal surfaces. It does not dissolve in the aviation fuels of the period the way petroleum lubricants do, preventing the fuel contamination that was destroying petroleum lubricated engines from the inside. And it adheres to metal surfaces through centrifugal force conditions that fling conventional petroleum oil completely clear of the bearing surfaces it needs to protect. The British and French aviation commands formalized castor oil as the standard lubricant for rotary aircraft engines across all operational squadrons by 1916, the United States. Army Air Service adopted the same standard when American forces entered the war in 1917. Official procurement records from the War Department document castor oil purchases in quantities measured in tens of thousands of gallons per month for aviation use alone across the final 2 years of the conflict. This was not a field improvisation or a wartime compromise. This was federally documented, formally standardized. Procurement-level military engineering policy built entirely around a substance that any pharmacy in the country sold over the counter for digestive complaints. The pattern repeated in World War II. Early radial aircraft engines operating in the extreme temperature and altitude conditions of high-performance combat aviation continued to rely on castor oil or castor-based lubricant. Blends in specific high-stress applications where petroleum and early synthetic lubricants demonstrated performance limitations. Technical Service Command maintenance manuals for several major aircraft types referenced castor oil. Blends in bearing and valve train applications through the early years of the Pacific Campaign. Knowledge was there. The performance data was there. Military documentation was there. Here's exactly why it works. And this is the part that makes the modern synthetic lubricant industry uncomfortable to address directly in any public technical forum. Castor oil is chemically distinct from every petroleum. It's derived lubricant in one property that determines its performance under extreme mechanical conditions. It is a hydroxylated fatty acid, specifically ricinoleic acid. Makes up approximately 90% of its composition, and that hydroxyl group fundamentally changes how the molecule behaves under heat and pressure compared to petroleum hydrocarbons. Most lubricating oils lose viscosity as temperature increases, thinning out and losing their ability to maintain a protective film between metal surfaces at the temperatures found inside operating engines. Castor oil's viscosity index, the measure of how much its thickness changes with temperature, is dramatically more stable than petroleum oils across the SEV. Temperature ranges found in internal combustion and high-speed rotating machinery applications. The hydroxyl groups in ricinoleic acid create strong intermolecular attractions called hydrogen bonds that keep castor oil molecules clinging to each other and two metal surfaces even under the heat and centrifugal forces that strip petroleum lubricants completely away from bearing surfaces. This is not a theoretical advantage. It is a measurable, documented property that was the direct reason military aviation engineers selected castor oil as the standard lubricant for rotary aircraft engines. After systematic comparative testing in 1915 and 1916, a study published in the journal Tribology International in 2008 tested castor oil as a lubricant against conventional mineral oil and a leading synthetic lubricant across a range of load and temperature conditions in a standardized bearing test apparatus. Castor oil showed lower wear rates than mineral oil across all test conditions and performed comparably to the synthetic lubricant at temperatures below 150 degrees Celsius, while outperforming both at boundary lubrication conditions, the exact operating regime, where lubricant film breakdown causes the metal-to-metal contact that destroys engine components. The study was published in a peer-reviewed engineering journal. It has never been cited by any major automotive lubricant manufacturer in consumer-facing materials. The global lubricants market generates over $60 billion in annual revenue. Synthetic motor oils alone, the premium price segment that has grown to dominate automotive. Retail over the past 30 years represent a major share of that total, with leading brands selling for $12 to $15 per quart in a product, category that petroleum companies have spent enormous marketing budgets elevating to the status of essential engineered technology. Every oil change interval reminder, every dealership service recommendation, every NASCAR sponsorship and technical endorsement exists within an ecosystem built around one commercial requirement: that you continue purchasing proprietary petroleum-derived compounds on a regular scheduled basis from a distribution, a system that petroleum companies control from extraction to retail shelf. Castor oil as a mechanical lubricant fits nowhere inside that system. You cannot extract it from an oil field. You cannot refine it in a petroleum processing facility. Cannot protect its formulation behind proprietary additive packages that require industrial chemistry facilities to produce. The castor plant grows in tropical and subtropical regions across 3 continents and produces seeds that any small-scale processor can cold press into finished lubricating oil without industrial infrastructure. A lubricant that can be produced locally from an agricultural crop, sold over the counter at any pharmacy for $2, and stored indefinitely without the degradation issues that require petroleum oil change intervals, is not compatible with $60 billion in annual lubricant revenue. It never was. And when the post-war synthetic lubricant development programs at Shell, Mobil, and Standard Oil produced patentable compounds that could be positioned as technologically superior to natural alternatives. The industry had everything it needed to complete the transition: proprietary chemistry, patent protection, marketing infrastructure, and the regulatory relationships necessary to have their products specified as standard in every automotive manufacturer's service manual from Detroit to Stuttgart. The knowledge never fully disappeared. Castor oil never left high-performance motorsport. Every major two-stroke racing engine formulation, from motorcycle road racing to karting to outboard marine competition, uses castor oil or castor-based synthetic blends as the preferred lubricant in applications where maximum film strength under extreme heat and RPM is the determining factor between a finishing engine and a destroyed one. Blengel, Maxima, and several other specialty lubricant companies have sold castor-based racing oils continuously since the 1950s to a motorsport community that never accepted the claim that petroleum synthetics were categorically superior under all conditions. The knowledge survived in the community. That needed real-world performance data more than it needed marketing materials. In the small engine, chainsaw, and vintage machinery communities across the United States, castor oil lubrication has been documented and practiced continuously by mechanics who discovered through direct experience that castor oil outperformed conventional petroleum products in specific high-stress applications. A machinist in rural Tennessee documented his use of pharmaceutical-grade castor oil as a cutting fluid and machine tool lubricant over a 15-year period beginning in 2005, reporting consistently lower tool wear and better surface finish results than commercial cutting oils at approximately 1/10 the cost. His documentation has circulated widely in machinist communities online and has never appeared in any publication supported by industrial lubricant advertising. For practical field and survival applications, food-grade or pharmaceutical-grade castor oil available at any grocery or pharmacy for $2 to $4 per 8-ounce bottle provides effective lubrication for hand, tools, hinges, locks, manual mechanical equipment. In any application where petroleum lubricants are unavailable or have degraded in storage, castor oil does not evaporate the way light petroleum oils do, does not wash away immediately in wet conditions the way petroleum lubricants do, then stores indefinitely without the oxidation degradation that causes stored petroleum oils to lose lubricating effectiveness over time. For a field kit or emergency preparedness supply, a single $4 bottle of castor oil provides more durable mechanical lubrication capability than a can of petroleum spray lubricant, 3 times its price with a fraction of its shelf stability. A British mechanical officer on a French airfield in 1915 reached into a supply crate, pulled out a container of castor oil, and poured it into the bearings of a rotary aircraft engine because every other option had already failed and pilots were dying. What he poured in kept that engine running through combat conditions that had destroyed every petroleum lubricant the procurement the system could provide. The pilots who flew behind that engine survived missions they would not have survived behind a seized engine. The knowledge of what kept it running was formally documented, officially standardized, and federally procured in quantities measured in tens of thousands of gallons per month. It was not a secret, it was federal infrastructure. A synthetic lubricant chemist at a major petroleum company in 1955 filed a patent on a proprietary additive package that could be positioned as technologically superior to natural alternatives, priced at a premium, and specified as standard in automotive manufacturer service manuals across the industry. He did not prove his compound was better than castor oil under all operating conditions. He proved it was patentable, and a market measured in tens of billions of dollars annually, patentable is worth considerably more than better. $60 billion in annual lubricant revenue depends on you believing that mechanical lubrication requires proprietary chemistry produced in a refinery and sold in a branded bottle at a $15 per quart price. A $2 bottle of castor oil at the pharmacy has been quietly disagreeing with that belief since before the first petroleum company filed its first lubricant patent. Subscribe and share this video. Every share reaches a man who will never walk past the pharmacy shelf the same way again, and who will carry a field kit that works regardless of what any supply chain decides to provide.